because one guy took the time to fit the data to the model. This is the key. Now, one of the things that let Kepler see this key was that in 1603, which is the last supernova in this galaxy, it was so bright you could see it during the daytime. Kepler saw the supernova, and that instant he realized this Greek idea of these beautiful, perfect, immutable heavens with these crystalline spheres was wrong, because the heavens were mutable. The supernova went blinking, it goes for a couple of weeks and it goes out, they changed. That led him to the next level that he needed to get to. And the supernova brings up an interesting point. How do you deal with events that you can't control? You can do an experiment in your lab, you can find a fossil, but there are things you don't control, like supernovas, or earthquakes, or volcanoes. But you still want to study them scientifically. So the way scientists get around that is to use multiple independent instrumented records. So you don't look at it with one telescope, you look at it with several telescopes. If I see a supernova in M31 in Andromeda, I call up my friend, another observatory, and he looks at it. So one supernova, I can say, well, you got a firefly in your mirror, and every time you look, it's pulsing, and it looks like it's a supernova, but really it's just a firefly. Okay, fine, well, I call up the Keck and Orion, and they look and say, I see the same thing, the supernova's in M31. Now, if I say the Keck's got a firefly, the mirror might be 100 square meters, you have to have a firefly in exactly the same place in both mirrors. That gets, the probability of that is astronomically small. And if I had a third telescope or fourth telescope, or I look at the gamma ray spectrum or the radio spectrum, because I'm seeing emissions in all the spectrum, it's very, very, very improbable that a glitch is going to happen in the exact same way in each of these different apparatus. This is the trick scientists use to deal with multiple transient events that happen very once or happen over and over again, but for brief periods of time that are uncontrolled. This is the program we need to find out what happened to Kennedy. Multiple independent instrument records. I do a lot of science there, but I think it's important. All right, first, let's look at what happened in the medical autopsy. Again, the body's private face evidence. It's clear this wound has been altered. The descriptions of the surgeons in Dallas, they only did a thin slice here to do a tracheometry. This looks like somebody went in there and dug around for a bullet. The head's been altered. The first thing the doctors say when he comes off the out of the wrapping of the box was surgeon the head, name at the top of the skull. This is written clearly in the CSIRO report. Once he says that, that's corrupted data. Once a medical expert says surgery of the head, and no surgery there we've done in Dallas, it's over. That's corrupted data. It's unpublished. If I try to publish corrupted data, not only will that paper get published, the next 10 will get published. Never, ever attempt to publish data that you know has been corrupted. You have to go back and try and reproduce it. That kills that out. But you can now look in comparison to this Bruder film, you just see this little flap, above the guy's ear, and then here you see all this massive carnage, damage to the top of his head and everything else. It's really, really egregious. So the bottom line here, I think, is that Kennedy is America's Piltdown man. And these are the autopsy records. This shows he's got a ruler here, and it looks like this may be lining up where the bullet wound actually comes in. If you look at the holes here, he's clearly getting shot in the back from the official autopsy. There's other corroboration for that, which is that his jacket and his shirt are all damaged in the back. There's no wound in the back of his neck. There's no wound in the back of his head. All this stuff looks like it's been faked up. The official autopsy photos, boy, a whole piece of his skull is missing. I mean, the front of his face is missing. His face would be sunken. His eye socket would be sunken. And nobody reports this. None of the pictures of Kennedy show this. Nobody at the Dallas hospital shows this. This isn't even his head. This is just egregiously fraudulent. But notice in here that he's got particulates in the front of the head. So whatever went in there drove a bunch of particulates in the front of the head. That has some importance. I'll explain that in a minute. But none of this has any validity. But the key thing is there's no wound in the back of his head, and the shot hits him in the back. All right, now we're going to look at the single bullet theory. What happens? The bullet comes in his back and it goes by his vertebrae here and it hits his lung. We know it hits his lung. Official autopsy showed contusion to the lung. In addition, the Dallas doctors had trouble maintaining integrity of the respiratory system because when they plugged his trachea, he still was losing air and was on the right side. And they were trying to put a hole in here before he expired. But we know there's damage to the lung from various things. So it comes in, hits his lung. Somehow, in the name of God, it's got to get from his lung to his windpipe. And the only way that's going to happen is if the soft tissue can redeflect the breath from that bullet. This bullet is moving 2,000 feet per second. It's almost twice the speed of sound. Its density is about 11 grams per cc. Bone's about 2 grams per cc. Tissue is 1 gram per cc. you're looking at a very soft tissue deflecting a hardened military round going 2,000 feet per second. It's ridiculous. It's like firing a cannonball at a piece of tissue paper and having it bounce back at you. But this is what this theory requires. And if it even did this, it still doesn't work because it clips his chin and it keeps on going. So even this nonsense does work. I don't know if Bugliosi took geometry, but in my book, 2 points form a line, and that keeps on going out through here. And in fact, the group in Adelaide, Australia, fired a live fire test with 2 dummies. And when I do radio interviews, they keep bringing this up, and I keep telling them it's disinformation, because even though the bullet passed through 2 dummies, they may be lined up horizontally for that to happen, the Kennedy and the Connolly in the car. It's the vertical path of the bullet that makes this ridiculous and impossible. And the first thing you saw in their video was it went right through his back and came out his chest. You can clearly see it on the video, but guess what? They never show you where it came out. They deliberately don't show you because guess what? It doesn't come out his neck. They don't want to tell you that. So that's disinformation. They're being dishonest because they're withholding a key piece of information. You can see it in the video, but they don't make a point of it. It's a key point. Because they leave that out, they're tricky. It's a discovery chain. Okay, so this model doesn't even work. Now I have to go to a more extreme model. It has to come in, bounce backwards off the lawn. Again, it's just your cannonball bouncing off the tissue paper and make it another extreme high angle deflection. There's a good show on television called Deadliest Warrior, and they go around there shooting hundreds of bullets each week at carcasses and anthropomorphic dummies. And not once, ever, I see, I must have seen 1,000 bullets on that show. Not one time I've ever seen a bullet go into somebody's body and come bouncing back out again. Because that's what this model requires. Anytime you make a deflection greater than 90 degrees, it's bouncing. It's bouncing. It never happens, not in real life. But somehow it has to do that bounce back, then it hits here, it does another bounce back, and it comes back here. So this is just beyond ridiculous. Unless Kennedy's bones are made of depleted uranium, where he's the bionic man, this scenario cannot happen. Oh. Got it. All right. The second thing that nails this is human reaction times. Both Connolly and Mrs. Connolly thought that Kennedy and Connolly were hit by separate bullets. What are human reaction times? Well, if you drop something, you have to have a friend. I guess I'll use a microphone. Have your friend hold a ruler in your hands and drop it, and you pinch your fingers. Now I know I'm dropping it, so I'm going to catch it, but you don't know when he's going to drop it. So that's an example of human reaction times. Your eye sees it drop, and it catches it. And that reaction time is about 8-inch drop, which corresponds to 200 milliseconds, about a fifth of a second. That's human reaction time. But Kennedy now coming out from behind the sign, his arms are clutching his throat. It's not a Thornburg maneuver. A lot of posers said, oh, it's a Thornburg maneuver. You look at the medical illustration, Thornburg maneuver is this. This is a guy clutching his throat. This is Thornburg. So he's clutching his throat because he got hit in the back at that point. He's already well into his reaction. But Connolly is sitting here pristine, unhappy, as a claim he's not doing anything. In fact, in the next frame, I believe his lapel flaps out, and some people with forensic analysis say, oh, this is when he was shot. Well, Kennedy's already been shot at least 200 milliseconds before. That bullet's fired at 2,000 feet per second. At 200 milliseconds, it's 400 feet, 300 feet downrange. That bullet's way downrange. It's not going to hit Kennedy. So the bottom line is that the distance between Kennedy and Connolly is 3 feet. The bullet's 400 feet downrange. This just, again, rules it out simply from the timing and human reaction time. These are simple experiments you can do at home. Because none of the evidence lines up with a single bullet theory, we can absolutely rule it out. The single bullet theory is an example of another marvelous theory shot down by a brutal gang of facts. All right. So, because of all this nonsense, again, once the single bullet theory fails, you know there's multiple shooters in Dealey Plaza. That's very important. People write reviews of my book and they say, Chambers has more credentials than Oliver Stone, but his book is not definitive. Well, I'm going to try to prove it today. My book it's beyond definitive. Because every one of these things that I'm showing you is a knockout punch for the government version of that. Every single one. If you have a series of knockout punches, you knock the guy out. All right, this is what the House did because there's so much confusion, and this brutal film aired on national television. There was a lot of impetus to open up the study of the assassination, including Martin Luther King and Bobby Kennedy and JFK. And so they actually there was a dictaphone recording that came to light, and they looked at the impulses on there, and they sent it to some real experts, people who did sonar analysis from the Navy, the Weiss and Atkinson and some other groups. And they concluded, yeah, these are gunshots. And they had a second group corroborate that, another university group, and they authorized live fire tests in Dealey Plaza, where they actually had people firing into sandbags from the grassy knoll and from the school repository, and they lined it up with microphones around the plaza to see what would match up. This is an example of acoustical waveform. There are different peaks in here because you get reverberations and echoes. This is what a waveform looks like. If you did an experiment in a bomb-proof and you look at an explosion and you measure pressure waves, because the acoustic wave has nothing to see with pressure waves in the air, it looks exactly like this. This is exactly what a pressure wave system looks like. And they were able to match up these waveforms with the live fire tests. And they got some very good agreements, and they got an extraordinary agreement for a shot from the grassy knoll. Well, the House doesn't believe in the shot from the grassy knoll, and I talked to G. Robert Blankley at length about this. He's convinced that the shooter from the grassy knoll fired a shot because it lines up with the data. It's a perfect acoustical match. But he missed. He missed. I've been on the grassy knoll looking down there. Boy, it's a hard shot. I think I could hit it. Hard to miss it. But he's convinced that the guy missed. And because of that, they didn't line their data up properly, and they couldn't get this match. But if you sync that shot up to Z312, you get an extraordinarily good match with the other shots. This shot comes in at 206-210. That's when Kennedy emerged from the sign. This shot lines up with a girl running along with the motorcade. He interviewed this girl, and she stops. And you can see in his uniform when she stops. He said, "Why did you stop?" She says, "I heard a shot. That's why I stopped." So you get an extraordinarily good match with all these data points, and this won't happen by accident. The House knew that the data points matched up if they just synced the grassy knoll shot with the headshot. So they did something stupid. Again, same dumb mistake. Let's base our model on the corrupted data. How dumb is that, right? The guy says surgery in the head. You know there's no surgery in down. The top of his head is corrupted. Base your model on that, but not, again, we'll do the other thing. We'll move the data. We had a data point, which is somebody drew a picture of a shot in the back of there. Well, that wasn't right. We'll just move that data up there and we'll get something that looks like this, but still doesn't match the beautiful. Same stupid things that the Warren Commission did. But the one good thing they did was this acoustical data, and they concluded that there's an extra shot here. There are multiple shots, at least 4 or 5 shots, but one of them's coming from that grass. And they concluded a conspiracy to assassinate. Well, what happens to the headshot from behind? Just look at this model. Google this. He loves this model. He spends chapters and chapters on it. What it requires is the headshot comes in the back of his head and comes out the side of his head. So that means your shot has to make an L-shaped turn on the side of his head. Again, you got soft tissue of brain redeflecting, redirecting a military-hardened bullet traveling 2,000 feet per second. Not going to happen. And then the jetting from this is going to knock his head back. Well, I got bad news for him. Most of the jetting is going up here. That has a very small component of momentum in this direction. And so it won't force it back unless this is ejecting supersonically, in which case you won't see it on 18 frames per second film. You'll see it on a high-speed film if it ejects supersonically, but that's not the case here. So the other way this model works is that shot comes from the other side of Dealey Plaza, and then you got another problem. Oswald can't be teleporting back and forth from Dealey Plaza, so now I've got another problem there. But the bottom line is the shot comes in and comes out the side of the cell, and it just can't happen that way.
Question?
And live fire tests done at Army Research Lab, guys fired, Dr. Olivier fired these shots and they just come out his eye socket every time. Nothing ever looks anything like this. So the other thing I wanted to mention to you was, if you, Bruglisi says the official autopsy is accurate, so you got fragments in the front of the head. Has a bullet come in here, throw fragments in the front of his head and exit out the side? How does it do that? How does it send fragments that way and exit out the side? Now I can fake this up experimentally by putting a metal plate in his head, and I can redirect the path of the bullet, but then the fragments can't go. So if your model is so bad that you can't even fake it experimentally, it's beyond ridiculous. And the other problem, it doesn't agree with experiment. And if your theory doesn't agree with experiment, it's wrong. It doesn't matter who thought it up, how smart they were, how many degrees they have, or how illustrious they are. If your experiment, your theory doesn't agree with experiment, it's wrong. The final fatal shot from behind theory is wrong.
Question? On the previous slide, could you go back? There seems to be a streak coming out of his head at about 80 degrees or so.
Yeah, I'll talk about that.
Do you have any idea what that is?
Yeah, there's probably throwing blood on it. What happens is the bullet's coming in very, very fast. So you've got an incompressible fluid, which is the blood in your head, which is also under systolic pressure. And it's going to spike the pressure up. It's also going to leave you an outlet. So once the pressure spikes, and plus you've got systolic pressure, where's the incompressible fluid going to go? It's going to come back out through the outlet. Again, if you look at the the Bad Universe show, when they shoot the asteroid in and hits the Earth, all the particulates ejected come back out. They can't go in, so they come back out. So you get a lot of ejecta coming back out. You see that also in sputtering phenomena and thin film surface science, things like that. But the bottom line is, the blood is an incompressible fluid, and you give it a hold to come back out, and you put it under pressure, so it goes flying back out. That's also, this sort of thing is characteristic of a high velocity round. Here's how we can see how it does that. A bullet comes in, this is called a ballistic pendulum. This is a device for measuring the speed of a bullet. And it consists of a wooden block on a string or a bar or some type of suspension. The bullet comes in with an instant velocity, little v and little m, because they're not very big, we make little m's and v's. And it lodges inside the block. But when it does that, the block must conserve momentum. So now the block with big M has to recoil with big V in this direction. But it turns out, because the conservation of momentum, you have a small thing moving very, very fast. Now a big thing is going to move very slowly because the MVs have to be equal. This guy is stationary to start with. This guy's moving. This guy lodges inside, and then this guy starts moving. The V must be small to compensate for the fact that it's very massive. And when it goes up here, you can use the little formula I showed you before, the 1/2 mv squared equals mgh formula to back out the velocity of the big V, and then use conservation of momentum, m little v equals m little m plus big M, big V, and you get an example for little v, which gives you the initial velocity of the bullet. And I'm just using a simple principle of physics called conservation of momentum. The bullet lodges in here, and the energy is lost to pushing things around and to heat and other kinds of losses. But the momentum must be conserved. And this is what happens to Kennedy. At 3:13, you can see zoom the jetting effect, bullets incident here. Prior to that, Kennedy's head moved slightly forward, okay? I don't believe he was ever shot from behind. I mean, I've looked at this brutal film down at the National Archives over and over, and the driver stopped the car dead in the road just before Kennedy shot. He's looking back at Kennedy. Now, if I'm the driver, I'm hitting the accelerator and getting out of there. He knows Kennedy's under stress. This guy is looking back, bang, slams the brake, stops the car dead, his head explodes, then he turns around and accelerates again. And so there's a slight forward movement, which I believe is simply due to the deceleration of the limit. Kennedy is listless, and when the limit stops, he just goes forward slightly. It's a very slight movement. But the next frame, 3:14, he's moving backwards immediately. Again, if it's a human reaction forcing that to happen, you can't do that within 50 milliseconds. About 50 milliseconds per frame. It's going to take him a couple hundred milliseconds. I mean, it takes me a couple hundred milliseconds to do that. Try him doing that. It doesn't make any sense. You can't do that instantaneously. So the people who say it's a muscle spasm are, again, fooling you and tricking you, and you can rule that out with simple experiments. But he recoils just like the ballistic pendulum. It's the same thing. He's sitting on a pivot, his body is suspended. Everybody says, nah, the bullet has to push against the full force of gravity. Wrong! That's the swing problem. The tension in the ropes is supporting the swing. Kennedy's back and neck are supporting his head against gravity. I don't have to worry about that. I'm just going to move him. It's just like being on a pivot on a swing. The bullet comes in and whoosh, and he moves back, just like in the ballistic pendulum. All right, so what bullet could possibly have done this? Now, the two clues are, one is the ejecta that you talked about coming out. One, that's a characteristic of high-speed round instruments. The second clue is that Discovery Channel actually did some live fire tests. They used a large caliber weapon, like a 30-30, and the round just punches straight through Kennedy's head. It just punches through. That's not what happened, because Jackie would probably been hit in that case. So they ruled out the shooter from the grass. No, they said, just didn't use the right weapon. With the right weapon is the small caliber round, moving very, very fast. And the fastest commercial cartridge you could buy at that time was the 220 Swift. And that moves a 50 grain round about 4,000 feet per second. It's a varminter, but people use it to hunt deer too. It can kill a deer a couple hundred yards. It gets spectacular one-shot kills. I talked to a gunsmith, and he said this was a favorite assassination weapon in the 1960s. And you can see why, because if you're going to hit somebody in the head, the bullet will remain in his head, especially if it's a frangible round. This is one of the things Sarah Weck told the House Committee, that because the right side of the head has got damage in it, and the left side appears to be undamaged, it's a frangible. It's just a round designed to come apart on impact. The particulate land inside of a copper jacket. And it also is consistent with descriptions of the X-rays, not the official X-rays, multiple descriptions of the X-rays by some doctors who said the pattern looked like stars at night. That's characteristic of frange go around where the metal lead particles are just breaking apart inside his head. And you hit him with that kind of velocity, it's the same thing that happens in the ballistic pendulum. The bullet goes in there and starts pushing things around and heating up, and doing all sorts of massive internal damage inside of his head. It's terrible stuff. But momentum must be conserved. So the momentum of the 220 Swift I worked out to be something like 3.72 kilograms per meter per second, which are units that physicists love to use. It's just a unit of momentum. The momentum of the head recoil, if you look at how fast his head's going back, is about 3.5. So you've got a pretty good agreement there, and a little momentum left over to move his back, to throw some fragments. I took into account the big fragment that's thrown out of there. But the bottom line, this gives a very good agreement. It's got enough momentum to do the job. And I think this is giving you pretty much the solution. The second issue I told you earlier, momentum is a vector, which means not only does it have a magnitude, and we got the magnitude to agree well with the 220 Swift, but we have to look at the direction. And if you look at the direction of Kennedy's head recoil, backwards, back and to the left, and trace that back out, that's going to give you the momentum of the incoming bullet. Not only do we have to match the magnitude up, we have to match the direction up. And when you match the direction up, from his coming at a 45-degree ping right there on the picket fence, that's exactly where the House Select Committee concluded the shot was fired from the grass and knoll. Now the odds of that House data matching up, not only did they match, could you match up frame by frame if you do that sync that I told you about, but they also matched up the speed of the motorcade. It went from microphone to microphone, matches the speed of the motorcade. That's very hard to do. 11 miles per hour. When that happened, they knew they were on the right track. If you get 5 shots to line up in the right order, matching the speed of the motorcade, and in addition to that, you match up all the shots from the Zaberta film, the odds of that happening are astronomically small. And people try to criticize that data, oh, it's not statistically valid. It's nonsense. It's like winning the lottery twice, 2 nights in a row or something. There's the odds of that happening randomly. That data is very, very solid, and then you combine it with this, a completely different technique. That's what I told you about at the beginning. Use multiple independent instrument records to get the answer. So we've got the acoustic records, which are scientifically valid, and the Zaberta film, which I'll discuss in a second, why it's scientifically valid. Film records are commonly used in science, especially in high-speed events, detonation physics events, distortions, impacts. Use a high-speed camera event. These films go millions of frames per second, too fast, to do in any kind of